Okay, so for the final problem here, I'm asking, assume that all LEDs have been initialized as outputs. So we're assuming that FIO dir has been set properly for all of the LEDs. So we've done the stuff we did in lab 1 and 2 to initialize the direction to make them outputs. So now we control whether they're on or off using FIO pin or the combination of FIO set and FIO clear. We're assuming here that LEDs P128, P129, and P131 are either on or off. It's asking to write a sequence of assembly instructions that makes P2.2 match P.1.28, 2.3 match P1.29, and P2.4 match P1.31, and saying that P2.5 and 2.6 should be off. So we're essentially trying to copy the light pattern from the top 3 LEDs to the bottom 3 LEDs, P2.2, 2.3, and 2.4. So we're assuming we don't know what the starting value is, so we're taking those from memory. So the first thing I'm going to do is get the address, move W, and then move T of FIO1 pin. So FIO1 pin is going to be the register that stores whether, or not the register, but the memory address that stores whether or not these lights are on or off. So this is going to allow me to get the current setting for P1.28, P1.29, and P1.31. And I know that they're on FIO1 pin because that 1 in the middle signifies that first number in the 1.28, 1.29, and 1.31. So it's bits 31, 28, and 29 on port 1. So the address that I need to put in here, and I'm going to put this in R1, is going to be hashtag or pound OXC034 in the bottom bits, and R1 move T 0x2009 in the top bits. So that gives me the address. Now I need to actually get the value, and I can do that by doing a load into another register, let's say R2, from address R1. So just like when we stored in the previous example to update the value, if we want to get the current value, we're going to do a load. And that's going to take whatever's in memory at FIO1 pin and put it into register R2 so that we can manipulate it with other instructions. So now let's do a little bit of logicking here. So I currently have bits 31, 30, 29, 28. These are the 3 that I care about. So those are going to tell me in R2 equals some bits here, and then it has 32 more or 28 more bits after that. But these are the 3 that I care about now. So I want to get those so that 28 is in position 2, 29 is in position 3, and 31 is in position 4. So to start off, the most simple thing I can do to get this close to the right place is to shift them. Since they are in the order that I want them to be in, roughly, I can shift this whole register over by 26 bits. That'll move the 28th bit over to the 2nd bit, and that way it'll be ready to store into FIO2 pin so that we can make that LED match. So I'm going to do a logical shift right on R2 using R2 as our input, and I'm going to do that by 26 total so that we can move that over by 26 positions. Okay, and so now in R2, R2 should be equal to a bunch of zeros over to the 7, 6, 5, 4, 3, 2, 1, 0 bit. These are sort of X values, like we don't know what they are. The 2nd bit here is the 28th LED value. The 3rd bit is the 29th LED value. The 4th bit is the 30th. 5th is 31. 6th is 7 and 6 are zeros because we did logical shift right, which means we're putting in zeros as we shift over. So we've moved over these bits, and I'm just kind of using 31, 30, 29, 28 as like the hypothetical values, so those could be 1 or 0. We're trying to match the pattern, so we're not sure what they are. So we've got 28 and 29 in the right spot now. That is where we want them to be so that the LED 2 will match whatever value 28 had. The LED 3 will match whatever value that 29 had. We have this problem just like in Lab 2 where the 30th and 31st bits are out of position because 30 doesn't have an LED and 31 does. So we need to try to move over 31 into 30's position, and we can't use the trick that some of you used for Lab 2 here because this is to the right now that we need to move this value. So we may be able to use that trick in some way, but I'm going to do it a slightly different way so that we can see how this works. So the first thing I want to do now is to extract this 31st bit into another register so that I can use this further on in the computation. So I can move it over, shift it to the right place, and then put it into that register. So I need to know what bitmap I need just to get the 31st bit. So looking at the bottom couple bits, I'm going to extract this by ANDing it with a bit field. Or a bitmap here. And if I look at the binary that I need, I can AND it with 2, 0 in hex to get just the value of that bit. So if it's a 1, it'll stay a 1. If it's 0, it'll stay a 0. And if it's a 0, we're doing some extra work here, but it's okay because we want this to be general so that it works whether it's a 1 or a 0. So I'm going to AND into register R3 from register R2 with OX20. So this is going to get R3 is the value of LED 20 or 31 now. So R3 has a single bit at the 5th position that tells us what this value is. So I'm also going to need to shift that over by 1. R3 is input over by 1 to get that into the 4th position, which is where I'm going to want it in the final output. So I want to put it there so that it matches 31 matches 2.4. Okay. So now I'm not sure what those values are. And I'm not sure if it's okay for me to just OR in this value or not over top of 30. If it was a 0, so like if the 31st pin was a 0 and the 30th pin was a 1, if I OR a 0 with a 1 that's already there, it's not going to, it's going to stay 1, and then our pattern's not going to match. So I actually have to clear out bit 30, and I also want to clear out bit 31 because we're specifying here that pins 2 and 5 should be off. So we want to make sure we get rid of any 1s if they are there. So that sounds like a bit clear instruction. So I'm going to do a BIC on R2 because that's going to be my final output with R2 as input, and I'm going to use a bit clear field. I want to make sure that I get bits. I know 7 and 6 are 0. I want to make sure I clear out 5 and 4, and then I don't want to clear 3, 2, 1, or 0. I guess I could clear 1 and 0 for good measure, but I may want to just leave those anyways. So I'm going to clear out bits 5 and 4 to make sure that they're zeroed, and a bit clear means that I can pass in a value that has the bits that I want to zero out, and it will zero those out. So I'm going to use OX30 here. That's going to clear out those 2 bits at the bottom for 5 and 4, and then leave 3, 2, 1, 0, and 7, 6 alone. So that's my bit clear. That's basically just clearing it out so I know that 30 and 31, the bits 5 and 4 are turned off so that I can put it back on if that value in R3 has a 1 there. And then the final step here is I'm just going to OR in from R3 into R2 so that whatever value I have in R3 currently, that should be the 31st bit that we've moved over to bit 4, that is going to get combined with what I already have in R2, which is the 2nd and 3rd bits set to whatever values we got from bits 28 and 29. So now I have the values in the places I want them. The last thing I need to do is store, and I'm going to do this in sort of a cheap way here to make sure that, just to sort of show that we can do it this way. So I want to store this into FiO2 pin that's right here. That's going to be where we have the values for ports 2.3, 2.4, and 2.2. So I'm going to store to that address I don't have it in a register yet. I'm going to store the new bitmap, which is R2, and I want to store that over top of the address CO54. And we'll see here that what I already have in a register in register 1 is CO34. So I'm going to do this in the sort of easy way, which is to take the address in R1 and move it over by OX20, which if we do the hex math, OX20 plus C034 is going to bring us to C035. So I can store to FIO pin or FIO2 pin by shifting the address of FIO1 pin over by 20 with this second argument from the store. And so this segment of code should take the values from pin 1, manipulate them, move them around so that they match up with pin 2's values or bit positions, and then store it back into FIO pin 2. Hope this helps. Let me know if you have any questions.